say a few things here so it's recorded. So log base 4 of x plus 2 minus log base 4 of x minus 1 is 1. I stated the domain for each piece. The common domain is this. I condensed, because it's a difference, is log applied to a ratio. Then the conversion, 4 raised to the first power equals this. Proportion cross multiply, x plus 2 equals 4x minus 4. This belongs here, this belongs here. 1 minus 4x is negative 3x, 2 minus 4, negative 2 minus 4 is negative 6, divided x equals 2 is in the domain, yes. Sorry, I forgot to turn it on again. Good. Anything else? Any other topic you would like to see? Anything else from your homework? Anything else? Any topic? We covered everything at least 3 times. It doesn't matter. Is there anything else? So what would you like me to do? Should I start chapter 5, which is not going to be on this test? Can anyone speak up, please? What would you like to do? Emily, what would you like to do?
We can keep working on my homework if nobody has anything.
Absolutely. Next question. Very good. What is it? Let me stop sharing. Good. Let's take a look. Okay, the bar graph shows the percentage of adults putting off medical treatment in 7 selected years because of expense. The function f of x equals 5.3 natural log x plus 18 models the percentage, so this is percent, good, of adults putting off medical treatment because of the expense. X years after 2000, so x equals 2000. 2000 may actually means x equals 0. That's what I meant to say. Good. Answer parts A and B. Use the function to find the percentage of adults who put off medical treatment because of expense in 2019. How well does the rounded function la la la? And then we have to look at the graph. So they're asking us to determine the percentage in 2019. What are we asked to do? We can stop sharing for a second. So we are asked to determine the percentage in 2019. Can you share one more time? So it said the year 2000 was the initial. So we're going backwards. After X years after 2000. So they want, 2000 and 2019. No, I'm sorry. Okay. So you can stop sharing for a second. So we're asked to find what happens, or what happened in 2019. What do we need to do? That's part A. And then they're asking us to look at the bar graph and identify whether this is a good model or not so good. based on the actual value. So this is an estimate from the function. But the actual value is in the bar graph. And we will have to compare it. But first we have to determine what happened in 2019. So what do we need to do? Any thoughts?
Do we plug in 0 or do we plug in 19?
We have to plug in 19 because this is not original.
Okay.
And I cannot plug in 0 in natural log anyway. So indeed, we have to find f of 19. I'm not going to plug it in. Who knows what they want next? So I want to see the function in y equals. So clear, 5.3, natural log of x, close the parenthesis, plus 18. And now I want to plug in 19. Of course, I know you don't have to say, Mr. Calculator, I know. Okay, so it's 33.6. And that is percent. Good. So now you can share again. So we can, so f of 19, we have to, if you want to enlarge the graph a little bit, so click on the magnifying glass several times. One more time. Good. So in 2019, it says at the top is 34. The function gave us 33.6%. So now let's read the rest of the question. So use the function to find the percentage. We did. The percentage of adults who will put off medical treatment because of expense in 2019 is this. So the function overestimates the actual percentage. So the function gave us a little bit less than 34 by 0.4%. So it does not overestimate. The percentage of part B, we read part B. The percentage of adults who put off medical treatment because of expense in 20 is this, which is the same as percentage. No, it's not the same. Now we are reading part C. The percentage of adults who will put off medical treatment because of expense in 2019 is, so the function underestimates the actual, yes. So the percentage that we got, what do they want? Oh, hold on. Round to the nearest percent as needed. Oh. In that case, we have to choose B. Because if we round the 33.6 to the nearest percent, it's 34. And it's 34, it's what the bar chart has. That's a little bit silly. But anyway, so we have to write 34 because it says round to the nearest. Yeah, that's silly. Part B, use the function to project the percentage of adults who will put off medical treatment because of expense in 2025. Assuming, they're not saying that, but that's wrong. Assuming that the model is still true. How do I know? So assuming this should have been in the sentence, assuming that the model is still true in 2025, determine the percentage. How do I determine the percentage using the function for 2025? Because that's what we have to find first. And then compare to, I don't know what, because the data doesn't exist. So maybe they are not asking us to compare. I don't know because I can't see the rest of the question. So use the function to determine, assuming the model still holds, what is the percentage of people who will put off medical treatment because of expense in 2025. So how do I find that?
Well, you have to plug in 25.
Indeed, of course. That's why I want the function in there if you want to stop sharing. That's why I want the function in there. So I don't have to plug it in over and over and over and over. It's already in there. All I have to do is put in 25, and that's it. 35.06. So now if they want, you can stop sharing. I can stop sharing, sorry. So now I don't know what they're going to ask. They want us to enter what? Round to the nearest percent as needed. So in this case, I will enter 35. And they cannot ask us to compare to anything because they don't have the data. The loudness level of a, oh, sorry.
Sorry, we can do this one too.
Okay, the loudness level of a sound D in decibels is given by the formula D equals 10 log, common log, base 10 in other words, 10 to the 12th multiplied by I, where I is the intensity of the sound in watts per meter squared. Decibel levels range from 0, a barely audible sound, to 160, a sound resulting in a ruptured eardrum. So the domain for I, in other words, is from 0 to 160. Okay, I took notes. The sound of a certain animal can be heard 500 miles away. That's the distance. 500 miles, that's D. Oh, reaching an intensity, okay. So that's the D is the level, no. So 500 miles, this is just information. So 500 miles and the intensity, which is I, 3.4 times 10 to power 8 watts per meter squared. Okay. Determine the decibel level of the sound at close range. Can the sound of this animal rupture the human eardrum? Okay, we'll see. Okay, so you can stop sharing. So all they're asking us at this point is to enter I this and calculate D. So let me remove this page. Okay. So D equals 10 common log of 10 to the 12th power times 3.4 times 10 to the 8th. So copy the base and add the exponents. 12 plus 8 is 20. So we have 10 common log of 3.4 times 10 to the 20th power. If it is more than 160, it will result at close range. It will result in a ruptured eardrum. If it's within between 0 to 160, it will not. But I have to find this. I can't do this by hand. We can partially, and I would like to do that. So 10, this is a product, log of this plus log of this. I bring 20 in front, and this is 1. And then I will show you how to enter it with the exponential as well. I'm not avoiding that. This is easier, but I'm going to show that to you too. So then we have log of 3.4 plus 20. And I'll show you that this is the same answer. Okay, so let's calculate. So first of all, we have 10. We have parentheses, and we have common log right here of 3.4. Close the parenthesis, don't forget. Add 20 and close another parenthesis. Exactly how I have it in writing. So this is the answer. Wow. So it's greater than 160. decibels. Okay, so this answer is 205. Okay, now the other way to enter it is 10 parentheses common log of 3.4 multiplied by this second in EE 20 and close. So in order to enter a power of 10, we have to use the second key and the comma. And when I press enter, I have to get the same number. If I don't get the same number, something is wrong. So that's another option for you with this E. This means 3.4 times 10 to power 20. 10 to power 20, second EE 20. Any questions on this calculation? Okay, so now you can share your screen, Emily. And let's see what they want. So, the decibel level of this animal sound is approximately let's see, round to the nearest whole number. So it was, let me look again, it was 205. Yeah, so you can enter 205. At close range, can the sound of this animal? Yes, yes, because it's over 160. Okay, so the graph of a log function is given. Select the function for each graph from the following options. So let me copy the options. I don't care about the graphs. We're going to graph them on our own, and then you will select them. So let me just copy h of x, log base 3 of x minus 1. Then uppercase h of x, 1 minus log base 3 of x. Then we have f of x, log base 3 of x. Then we have uppercase f of x, which is negative log base 3 of x. G of x, which is log base 3 of negative x. And finally, lowercase g of x, log base 3 of x minus 1. You can stop sharing now. So let's discuss each and every one of them. So when I look at all of them, what is the base function in all these? Can anyone identify the base function?
Would that be log base 3?
Of course. Of course. So in all of them, I'll start with this, of course. And here it is. Base 3 greater than 1, this is it. And it crosses at 0, 1. I'm sorry, of course, 1, 0. Log base 3 of x. So this is done. So if you want to stop sharing, share so we can find f of x. So which one is f of x? 47, 48, 49, 50, 51, and you will enter it when you. So remember, it has to cross at 1, 0, and it has to be increasing. If it crosses anywhere else, this is not log base 3 of x. So it has to be
52.
So it's 52. Is there anything else? 246, 246. Good. That is 52. That is 52. How do you select 52? Okay, got it. Good. So stop sharing now. Good. The next one. This is a good one as the next one. what will I do to this graph to determine this or to graph this? I like this exercise.
Move it to the left 1.
It's not in parentheses. So I'm not changing x. If it's in parentheses, if you want to start with that or continue with that, is this. Yes. So if it's in parentheses, I'm changing x into x minus 1, which means a shift to the right. So, okay, that's fine. So this graph will be from 1 moving to 2. So this is log base 3 of x minus 1. A shift of 1 to the right. And I have to shift the vertical asymptote first. And I have to correct my graph. That's what rushing does. So when we graph a function with asymptotes, we always graph the asymptotes first. And the original asymptote was x equals 0. Now the next asymptote for the next graph is x equals 1. Because the domain is 1 to infinity. So now you can go back. So let's choose the graph. It's tricky. They're not presenting the correct graph. I don't see the vertical asymptotes, or they're there. I don't see them. That's not nice. Okay, it's the 1, yes, I agree. And it's uppercase G of x. Oh, no, sorry. You're right, I'm sorry. Yes, that is the 1, although it's an incorrect graph. It does not have the vertical asymptote at 1. Okay, you can stop sharing now. Moving on. So let's come back to this one. What does this do to the original base graph? We're not changing x, we're changing y.
So would it go down 1?
Exactly. So this point now moves here at 1, negative 1. So 1, negative 1 is this point now. And this is the graph. No asymptote change. So it crosses to the right of 1. But it has the same asymptote, x equals 0. Good. Let's see. Yeah.
Is it 49?
Because there is nothing else. Good. Now let's stop sharing. Good. Now, this is the original graph. What does the opposite of the y value? I'm not changing x. I'm just putting a negative in front of all y values. How will this graph look like by comparison to this? When I replace y by negative y.
It reflects, right?
Exactly, with respect to the x-axis. So instead of this, it will be this. And it has to cross at the same thing, 1, 0. It's a reflection. Perfect. With respect to the x-axis. So it's decreasing, and it has to cross exactly at 1, 0, exactly. So that is uppercase f of x. Correct. Good. Stop sharing. Good. So now I'd like to see, this is the same thing, but plus 1. So what does this do to this one? I'm not changing x. Again,
So does it shift it up by 1?
exactly, absolutely. So now the graph, instead of being here at 1 comma 0, it will be up here at 1 comma 1. So that's uppercase h of x. So you can share. So it will go up and it will cross at 1 comma 1. Yes, exactly. That's it. Although we know the answer, let's discuss the last one. Okay. So now I'm comparing these two now. X with the opposite of x. X with the opposite of x. So what will this do to original function? When I change
Does it reflect on the y-axis?
exactly, of course, which we knew. So instead of being this, it will be this, and it will cross at negative 1 comma 0. Exactly. It was a very nice analysis.